A patient came in to see if everything turned out alright with her eye. After explaining her results, she asked about how phototransduction worked, since she overheard one of the nurses talking about it. It was explained and simplified for the patient to understand. Phototransduction is having light go through the retina, and once the light goes through, it splits into two, the rod cells and the cones. Then the first one is the cone, which is a girl, and the rod cell, which is a boy. The girl is much more colorful, which is what a cone does. It allows for one to see color. While the boy, the rod cell, is someone who keeps things simple and allows the light to pass through. Though the rod cell keeps things simple, it does not like the light, so it goes off. But in the dark, it goes on. It's almost like a vampire. So the spark, being the photon, is what allows for the light to be seen in the rod cell. Rhodopsin collects the light after, and opsin, a protein molecule, is what takes some of the light and forms it into 11 cysts. 11 cysts is a retinol, which is a photopigment that absorbs light. No changes occur, and rhodopsin causes drama that goes from one person, the G protein or transducin, his secret name, to 3 others. One does not do much but sticks to his friend GDP, and the other person, the altered rhodopsin, talks things through with the G protein and exchanges GDP for GTP. The alpha out of the 3, phosphotriesterate, PDE, allows for cGMP to break down. cGMP is sneaky and is different in the light and in the dark. In the light it is taken away, but in the dark it is used to open up the sodium channel. Although GTP takes from cGMP, GMP occurs after it has lost concentration. It was helped to change into GMP from cGMP by protein kinase G. Even after all of it occurred, the channels were open. In the dark, the voltage-gated potassium ion channel allows for the potassium ion to pass through, and hyperpolarization occurs. The ions create a flow, and depolarization occurs after there is too much, and it causes it to go down. So, the calcium ion is to increase the synthesis phase, and it is part of its key component. The sodium, calcium, and potassium exchange pump is a process in which 2 potassium ions go in and 3 sodium ions come out. 2 calcium ions go in and 2 potassium ions come out, and 3 sodium ions go in and 1 calcium ion goes out. After the entire process is done, glycolysase helps to bring the levels back up to the cGMP. Though that was only to one side, the other main part is that the cGMP is less than before, so the sodium channels close, thus resulting in hyperpolarization since the sodium ions are low, and it turns PDE off.